Okay, in this video, I will be covering the YTSS Prelim 2022, the practical. So this is Q2. So for Q2, in this video, the most important part is actually on how to check whether one value agree with another value. What is the acceptable tolerance that we can accept to say that these two parameters are the same. So anyway, in question 2a, for those of you who got very weird H0 value like 3 cm, that's because you didn't read the question properly. I only want the distance between A and B, and you should give me a value that is like 1 cm. I have checked this many times, cannot be wrong. It's 1 cm. And then in part C, I just want to highlight one more thing. You cannot get the precision from the instruction, because in the instruction when we say 5 cm such as this, it means that we will accept a range between 4.5 to 5.4. Okay, the word 5 cm, right, doesn't mean that the distance should be in a whole number, right? You should still follow the precision from the equipment that you use in your measurement. For your part D, there are many ways that you can get a better accurate reading of U. We accept a huge range of answer. One answer could be as simple as you make a marking on the retort stand before you actually mount the balls, right? So any change to the method that will make it more convenient or easier to get the reading will be accepted as an answer, right? One surefire way is, of course, just like the pendulum bob, you can measure half the length and then you measure the distance between the table and the bottom of the lens, and then you just add D and H up to give you the U. So this is a more lengthy approach, but most of the time it works. Okay, so this one, if you are not convinced why your answer is wrong, you can always come and see me and then we can discuss, right? For part E, H1, actually our magnifying glass is 3 times, so I accept a range between 2 to 4. There's no unit for the magnification. Then after that, the question asks you to describe one difficulty in getting H1. We accept a range of answer. However, we do not accept reasons like the image is blurred or distorted, because if you do not know, our eyes will auto adjust and cause the image to be always sharp. So if you look at when you put your thought to it, and then if you want to look at certain thing, right, the thing will always come back to you sharp, right, whether it's far or close. That is the beauty of our biomechanical lens in our eye. So you will never get a blur image if you are seeing things, right? For part G, like I said, magnification, I will accept a range from 2 to 4. Focal length, you just measure, follow least SF. Please take note, this 1 over here, it is not included in your least SF consideration. Okay, because this 1 is an exact number. Similarly, this 2 over here, right, is also an exact number. So when you have exact number, you shouldn't use them you shouldn't include it in your consideration for your least SF. And remember, you should never give 1 SF, right? If you end up with something 1 SF, just up it to 2. For part I, not much of an issue. Anyway, for part I, right, I know that it is very hard to obtain the sharp image. So if you have difficulty obtaining, and after you raise your hand and the SS tell you that, hey, nothing is wrong, just carry on, just try your best, get an estimate and then move on, right? Remember, only question 3 requires all the reading to be taken properly. Question 1 and 2, the reading is just like a test of precision rule. Okay, so chill. Then for J, like I said, I will share with you how do you consider whether something is the same or they are not the same. So whenever you are asked to explain whether you agree or disagree, do not just stop at the difference, right? Let's say my wallet versus your wallet has $10 difference. Well, $10 difference, is it too huge a difference or too little a difference? That really depends, right? If our saving account is you have $30 and I have $40, and a difference of 10 is quite huge because it's significant, right? But if I have $2 million and you have $5 million and our difference is 10, then out of the millions of dollars in our bank account, $10 is nothing, right? So because of that, when we want to check whether something is agreeing or disagreeing in practical, then we should always look at the percentage difference, and percentage difference is given by this expression. Now, what if you really run out of time and you just want to get a sense of it? Now, here's the rule of thumb. It really depends on the size of the value that you are comparing. If you are comparing something that is in like 2.34 versus 2.38, as long as the second figure here agrees, it means that it agreed. So similarly, if I look at this set of reading, right, if this value doesn't agree, then it doesn't agree. So for example, if let's say I have like 13.55 and then I have like 13.67, well, this is my first figure, right? 1 is my first figure, so I will look at the second figure. So if the second figure agree, that means it agrees. That is the rule of thumb, right? So for example, if I have like things like 124.5 and I got 127.8, well, this is my first figure, and I will look at my second figure to see whether it agree or not agree. So if the second figure agree, that means agree, right? How about this one? 0.342 versus 0.38. So this is my first figure, the zero no count, right? First figure agree, and then I look at my second figure. Oh, second figure don't agree, right? Second figure don't agree means these two are not the same, right? Let's give ourselves one more example. So I have this. This is my first figure. My second figure agree. If my second figure agree, that means they agree. Okay, so this is like a rule of thumb that you can follow. If the question doesn't ask you to explain, this is how you can decide very, very quickly. Can? So that's all for your question 2. If you have any question, please come and look for me. Your